Good morning. This is the first course in ICEM Hexa. ICEM is a pre-processing software for CFD analysis from ANSYS. It's one of the most powerful pre-processing softwares out there in the market today. Being powerful, it's also very difficult to learn on your own. Its difficulty stems from the fact that it takes a different approach to meshing. And the motive of this course is to train the student into and the new user in a much more efficient way of tackling complex geometries using ICEM Hexa. Please note that the course concerns only with the hexahedral aspect of meshing using ICM. The tetrahedral mesh, which is much more easier to learn, won't be covered in this course. My name is Vishal Anand, and at the time of making of this video, I am a PhD student at Purdue University in the US. My expectations from the student is that they should learn the modules sequentially. They should not skip the modules, as in you should first start with the first module, module 1, and then go on to module 2, module 3, and so on. Please do not skip the modules. And also there has been a presentation uploaded in the description part of this video. The presentation explains in detail the various options available in the ICM CFD GUI. So you should read the presentation in tandem with the video lectures. So we are in module 2, which concerns with intermediate geometries. The geometries discussed here are a much more complex form of geometries in module 1. In this particular video, we are going to deal with 3 cylinders attached end on end. So this is how the geometry will look like. There are 3 cylinders. This particular geometry is a more advanced form of the geometry discussed in module 1, which was 2 cylinders attached end on end. So before we go on to these 3 cylinders, it's my suggestion that you should revise the video lecture on 2 cylinders of module 1. So this is what the geometry looks like in the current problem. There are 3 cylinders. The 3 cylinders are of different diameter each. This is the largest and the main cylinder, and this cylinder is larger, has a larger diameter than this one. So this third cylinder has the smallest diameter. So we will discuss first what the blocking philosophy would look like here. First of all, we will initialize the block and then make splits at the point where the topology changes, where one cylinder ends and the other cylinder begins. So we will make a split here and here after initializing the block, and then we will create an O-grid throughout the block to capture the larger cylinder. But that O-grid won't capture the smaller cylinder, so we will make another O-grid within the previous O-grid to capture the smaller cylinder. So we will make 2 O-grids throughout the block, one each to capture the 2 cylinders at the end. And then for the larger block, we will delete the outer blocks only once. But for the smaller cylinder, we will need to delete the outer blocks twice, one for the O-grid and one for the main block. Things will become clear when I proceed with the geometry with the ICM. So you create a block, you split where the topology changes, and then you create an O-grid. The O-grid captures the outer block, the larger of the 2 cylinders, but it does not capture the smaller cylinder. So to capture the smaller cylinder, we make one more O-grid. Inside the O-grid, another O-grid is created, and this O-grid will capture the smaller cylinder. And after the O-grid captures the 2 cylinders, the outer blocks will be deleted. For the largest of the 2 cylinders, all the outer blocks will be deleted. For the smaller of 2 cylinders, the outer blocks as well as the blocks pertaining to the outer O-grid will be deleted. And then we can associate, and that's it. we may want another O-grid to improve the quality as well, as we generally do. So without wasting much more time, let's go on to the ICM. So this is what the ICEM GUI of this model looks like. For a speedy tutorial, I have already created the parts. This is the main cylinder. This is the main cylinder, and then we have uh, the two cylinder one and cylinder two. The larger diameter cylinder is cylinder one, and then cylinder two is the other cylinder. We have the inlet and also the outlet here. This would be the outlet. This is the outlet, and we have the of course the walls. And the curves and the points have been grouped together in a separate part of their own, as has been our convention throughout this course. So this is the part creation for this geometry, and then we go on to creating the block. We initialize the block as usual with, let's say, part name fluid. And the part name will be created right away when we initialize the block with no entities selected, because we want to select the whole of the geometry here and then say apply and say dismiss. So we have the block here. Now the first thing is that we split the block, because we want to capture the geometry. So we've split the block at the point where the diameter of the cylinder changes. So we make a split here and we make a split here to capture the change in geometry of the change in diameter of the geometry. So make a split here, split block, and then edge, and then select this here, then middle click, and then again here, and then middle click. So this is the split, how the split looks like. The next option would be to create an O-grid to capture the two cylinders. This is a larger diameter cylinder, so we will create an O-grid throughout the geometry to capture this cylinder. We create a split. Let's switch off the surfaces. Select blocks. We want the block O-grid to be created throughout the geometry, so we select all visible. Select faces, we select this face and this face, and then middle click to confirm and say apply. So this block has been the block has been divided into O-grid. Uh, we want the O-grid will snap to this larger cylinder here, but it should not snap to the smaller cylinder here, because that would distort the elements a lot. So it's better, we would not use this O-grid to capture the geometry of the smaller cylinder. We will use this O-grid to capture the geometry of the larger cylinder only. So to do that, we will create one more O-grid, uh, which will be which will go through only through the innermost blocks. So this is the innermost here, and this is the innermost here, and this is the innermost here. So we press middle click and we press save, select faces here, then say apply. So we have created an O-grid inside the three blocks as well. So there are two O-grids. So let's do the association now. So we begin the association. We associate the outer block to the biggest cylinder. So, and then we associate the first O grid to the larger of the two cylinders. This is the first O grid. Look at my cursor. This is the first O grid, the outer O grid, and we'll associate it with to the larger of the two cylinders, which is this one. This cylinder is larger than this cylinder. So we'll associate this edge here to the curves of the larger cylinder. Let's apply. For continuity, we should also associate the edges of on this face, on the face opposite to this, with the curve here. And then for the opposite cylinder, for the cylinder on this end, we will associate the smallest of the O grid. This, please look at my cursor here. This is the smallest of the O grid to this cylinder, which is the smallest of the cylinders. Apply. To check whether the association is correct, what we can do is we can switch on show association here. So we see that these edges have been applied to this curve, which is correct, and the edges of the outer O grid have been associated with this red curve. So we are good. And of course we should associate the O grid on this face also, which is opposite to the face of the smaller cylinder. We'll associate that as well. So the O grid association is complete. Now we do the usual project vertices. We switch on the vertex and then we say apply. So as usual, as was done in the module 1 video lecture on the two cylinders, we will now have to delete the outer blocks, which will help us to capture the geometry. So for the smaller cylinders. So let's do that. We will delete the outer blocks here on the larger of the two cylinders, and we'll also delete the outer blocks here. But here there will be two sets of outer blocks, one belonging to the main block and one belonging to the O grid, because the outer O grid is not attached here, so that should be deleted. Here the outer O grid is attached, so we will only delete the blocks pertaining to the main block. So things will become clear as we watch. So we delete the blocks. So we see here we have selected the blocks which are outside the O grid, which belong to the main block, and which end on these vertices here. I can show a zoom view. These are the outer blocks which we are deleting to capture the geometry well. This is very similar to the module 1 video lecture on two cylinders that has N on it. So I press middle click and then I delete. So now you see the geometry is captured better. The edges are coincident with the curves. Similarly, we also we will delete the outer blocks here, but there are two sets of outer blocks, so we'll delete them set wise. So this is the outer block here, and then here, and then here, then here. So we will delete the two sets of blocks here. We have now these are the blocks selected right now which are part of the main block. So these will be deleted anyhow, and then say delete. And then we have one more set of blocks here remaining from the outer O grid. This was not there in the older cylinder uh, because the other cylinder had the outer O grid attached to itself. So we will delete one more set of blocks here. And then press middle click and press say apply. So this is how now we have been able to capture the geometry pretty well. Uh, so we will now give the node distribution on the edges. So this is let me check whether the every edge has been given distribution. Yes, it seems like we are missing here. So we have given a distribution to every edge, and then we switch on the pre-mesh. So a mesh is created. For better visualization, I switch to solid. Switch out the edges. So you see, we have been able to capture the geometry pretty well. The geometry, the mesh is very tightly grips the geometry. The contours of the mesh and the contours of the geometry are coincident. The topology is perfect. We have been able to capture the topology very well. But again, here we see we run into the same chronic problem while meshing cylinders. We see bad quality elements here. I mean, you can do a quality histogram and check. We have sub angles between 29.79, which is here. I mean, we should make the mesh a little finer. Uh, then the quality of the angle becomes worse. So that's the problem with meshing a cylinder without going into the interior. So and we know how to improve the mesh. We have done it many times in this in this course. So we will create one more O grid inside the cylinder to capture the to capture the curvature of the cylinder inside. It will improve the quality of elements. So we will create one more O grid here, and we select block and we select the innermost block. We have selected the three blocks, which are the innermost block in each of the cylinder. And we select the faces. This is the face. This is one of the faces, and this is the second face here. We say apply. So we have been able to create one more O grid, and we will then just give a distribution on the edge here. say like 4. So we created one more O-grid. The function of this O-grid, the intent was to improve the quality of the mesh, not to capture the topology. The topology has been already captured. I remove the edges. So we see here that the mesh has improved. The mesh looks prettier, and here also there is no bad there are no bad angle elements here as well. We can confirm this hypothesis as usual angle, and we see that the angle has improved. The minimum angle is like approximately 45 degrees, which is pretty good. We can scale the mesh. Let's say size apply. We scale the mesh by a factor of 2. A factor of 2 means the mesh will become finer because it's more than 1. 2 is more than 1, so mesh becomes finer. If it had we chosen a factor less than 1, the mesh would have become coarser. So a factor of 2 makes the mesh finer. Mesh becomes finer, but still the angle is pretty decent. 44.55 is extremely good. Minimum angle of 44.55 is extremely good. So the angle doesn't change while changing the mesh, scaling the mesh. Even if I do 2 once more, even then the angle won't change. You can keep making the mesh finer and finer, but the minimum angle won't change. So that's the beauty of this mesh. Once you create an O-grid inside the cylinder, the mesh quality improves drastically. Let's leave it at 0.3, 0.5. We'll make the mesh coarser. One more. So that's how the mesh is, and this is the end of this video lecture. Thank you.